Hi everyone, this is D Pranay Kumar from class CSCC section. Now let's gonna discuss about the new topic called as a new way of power supply for railway cars. So, as all of you know, that British has brought railways to India, which was more impactful from that time to this time. So let's look into that. Let's look into the history of Indian railways. On 16 April 1853, the formal inauguration ceremony of Indian Railways was performed. Britishers had developed railways in India. The main motive behind the railways is railways helped them in economic development of India by benefiting government with a return of 5% of its investment. So, the main motive behind the Indian Railways is that not for the public, but they have brought the railways in India by thinking of the trading purpose, which helped them 5% of its investment. So, let's look who bought railways to India. The General Lord Dalhousie is known as the father of Indian railways. In 1849, General Lord Dalhousie was appointed as the Governor General of India. He imposed railways in India for trading purpose. So, next, let's look how the usage of railways in our lives affected. Trains make our journey easy and affordable. At very nominal rate, you can travel very long distances in short span of time. You can even explore the smaller, less known distances by train. Local trains also make the life of working people easier. Yeah, that's true. So, let's look how many types of trains are there. So, when the railways was started, when the Britishers started the railways, there were steam trains which used to run by steam. And now, from last from past 15 to 20 years, the network has changed, and they were now it's going on with diesel trains. And for the future, the diesel trains will also disappear and electric trains will come. So now let's look into the electric trains. How electric train works: it is a locomotive powered by electricity from overhead lines. They may be less pollution compared to the diesel and steam trains. In coming future, almost all trains are going to be electric rather than diesel. And also electric trains are cheaper than diesel. But there is a system which complexity and maintenance. So these are the advantages and disadvantages of the electric trains. Next, now let's look into the new way of power supply for railway cars. So, exacting specifications for modern railway car power supply, together with the necessary for extreme simplicity and reduced maintenance, rendered a new type of power supply desirable. This led to a development of motor generator exciter system, which together with its associated control represents a major advance in the art of the railway car power supply design. So, which is a new and the best way to do. Such a system must be automatic, reliable, require minimum maintenance, and operate successfully over a wide range of temperatures and atmospheric conditions. Yeah, the meaning behind is it should be automatic, means by overhead power lines, and they should be clean, neat, and etc. It must provide satisfactory supply to the connected load at essentially constant voltage over a wide speed range. Control must be supplied to assure that a limit is placed on a maximum current which can be taken from the generator. The generator and regulator must be coordinated to provide stable operation at any speed throughout the entire range. The generator must be able to accept the instant application by dumping of full load. At the speed range, as the speed range increases, the problem of designing a stable machines becomes more difficult. The system presented an added problem in that both the generator and the exciter had been designed as stable machines. Next, different capa- different capacities of batteries used by various railroads require the axial generator designed to provide for nominal systems of 40, 80 and 140 volts and to be capable of charging either nickel, alkaline or lead acid batteries. So these are the voltages and the elements which are used for the normal railroads required. The new rotating equipment consists of a 4-pole DC shunt generator, a 6-pole exciter, and a 4-pole 3-phase 60 cycle 220-volt induction motor assembled on a common shaft. This machine has driven either from the car axle or from wayside power. Next, the control equipment includes an AC panel mounting a line contactor to overload relays and an unloading relay and a DC panel mounting a line contactor, a voltage regulating relay and a current regulating relay, a reverse current regulating relay and a fuse or overload relay. When the generator and exciter are not running, current is fed from the battery through rectifier RT3 to the exciter field. Rectifier RT2 blocks this current so that it will not flow to the generator. It's like electrons opposing the current. As the set comes up to speed, the exciter buildups because the exciter field polarity is always the same. The exciter armature polarity will reverse with the reversal of rotation of the set. The generator field connected directly across the exciter armature will likewise reverse with set rotation. Since both rotation and field current are reversed, the generated polarity will remain the same and an armature reversing switch is unnecessary. Next, as long as the generator voltage is higher than the battery voltage, the series coil of RC acids, the shunt coil, when reverse current flows, the series coil bucks the shunt coil. This causes RC to drop out and open the generator contactor. The voltage regulating relay VR has its contacts connected in the exciter field circuit, which the generator voltage rises to the value to be regulated VR starts to pick up. This reduces the exciter field current and hence the generator voltage. VR then drops back to its original position. Yeah, that's good. This action continues and the relay vibrates in its normal closed contacts. As the generator speed increases, VR operates more in the open position than in the closed. And finally, the contacts move on to the outer side and vibrate against the normally open contact. The current regulating relay CR is similar in construction to the voltage regulating relay. It has two bias coils and the coil connected in series with the generator output. When the line current reaches the predetermined value, CR picks up and reduces generator voltage. This drops out VR. CR then takes over the operation of the system and vibrates against its stationary contacts to hold the proper amount of current. Devices have been selected to include as many common parts as possible for each of the three voltage ranges provided. Circuit components they have been largely employed. The amplification provided by the exciter permits applying the regulating relay contacts at the low volt ampere level, including almost the control power, lowers the temperature of the control locker and adds on the life to all equipment mounted in it. So, two simple relays having a total of two double throw contacts replace the 20 contact multiple finger voltage relay formerly used and weigh only about one sixth as much. The armature reversing switch has been eliminated, and in addition available speed ranges have been increased. Yeah, this is the new one in the electric cars. So let's see the schematic connection diagram of the railway cars. This is start stop button and the coupler socket, and these are the RTs which I have explained in the previous slides. Elect circuits, car battery, maintain main fuse, etc. Conclusion: with this new system, it is possible for extreme simplicity and minimum maintenance for railway cars. As all of you know that the nowadays the bullet trains are coming, which have more speed, and as well they are soundless and etc. So the advantages and disadvantages of these electric cars is that the advantages are they are they are easily accelerated, they are soundless soundless, which makes the environment a noise free a little bit. Thank you.